Okay, so this time we're going to graph a secant function. The process is very, very similar, except the reciprocal this time is going to be cosine instead of sine. So first we're going to look for our A, B, C, and D. A is 2, B is pi, C is 1, and D is also 1. Okay. So now we're going to look for the starting point. Normally a cosine function, without any changes, just the parent function, starts at 0, 1, which is its maximum instead of the intercept like it was for sine. But we still have to add c and d. So we have 0 plus 1 for c, for the x coordinates, and 0 plus 1 because the d value for the y coordinates. So we're going, this should be 1 plus 1 because we started at 1. So this time we're going to start at 1, 2. 1, 2. Yay. Okay. On to finding the period. Our equation is P is equal to 2 pi over B. So we have 2 pi over pi is equal to a period of 2. So so the entire length of the graph is going to be too long, but we're starting at 1. So the graph is actually going to end to past that, 1, 2, 3. That will be somewhere where x is equal to 3 will be the last point in our period. Now we're going to find the other 3 points in our period. Every period is 5 points long. So, and they're each equally spaced. So our third point is halfway between 1 and 3. So we have 1 plus 3 over 2 to average them. We get 4 over 2 is 2. So we have 1 point here. Then we find the other 2. There's 1 halfway between 1 and 2. It's equal to 1.5. And halfway between 3 and 2 is going to be 2.5. So 1.5, 2.5. And we won't need that part of the graph. So we have all of our x coordinates now, but we still need to find where on the y-axis they are. So we're going to find the amplitude. The amplitude is how far above or below the intercept line, which is actually here. Well, this is our maximum. In the sine graph, the intercept is where the graph starts. In a cosine graph, it starts at a maximum. So this point is however many above the intercept. So it's the absolute value of A. Absolute value of 2 is equal to 2. So if this is our intercept, this x-axis, 2 below that, is going to be if this is our maximum, 2 below is our intercept, and 2 below that, at -2, is going to be our minimum. So a cosine graph, a positive cosine graph, which is what we're doing right now, starts at a maximum, goes to an intercept, then to a minimum, then to an intercept, and back to a maximum. So then we can just sort of sketch that in, and it looks kind of like that. So now we can actually start what we're actually trying to do, which is graph the secant graph. Secant has asymptotes in it. Asymptotes are lines that the graph will approach but never actually touch. And in this case, they're at the intercepts. So we're going to sketch in dotted lines to show our asymptotes at both of the intercepts. Sort of like that. The actual graph of secant is sort of U-shapes that come out from the maximum and minimum points. So we have one here, and they sort of approach, like I said, they're approaching the asymptote lines, but never actually touching them. So we can also draw them in up here. I haven't drawn in or marked the asymptotes on either side, but any of these trig functions, a sinusoidal graph, can continue on forever in either direction. So they are there, I just haven't drawn them in, because we're only graphing one period. Then we can erase what's left of the cosine graph that we don't need anymore. And we have a secant graph.